In this problem, we are asked to solve for the power absorbed by the 2 ohm resistor. Okay, so before we begin our solution, you have to remember that to determine the power of a certain element, it is equal to 1/2 times the voltage of the element times the current in conjugate, where V is the V magnitude, angle theta V, and I is I magnitude, angle theta I. So we need the voltage and current in order to solve for the power of the certain element. And so let's start with our solution. So you may prefer any methods of analysis, but I prefer the nodal. So taking this as my reference node, and in this case we have a supernode at the top, this one. So that means that this node is 150 angle 20 volts, and the other non-reference nodes, you have this one, non-reference nodes, you have this one, and the other is this one. So I would denote this as VA and this one as VB. So for VA, our equation, we have 1 over J4 plus 1/3 plus 1/2 minus VB, the neighboring node, we have 1/2. And don't forget the supernode, 150 angle 20 times 1 over J4 equals 0. And so VA, by simplifying this, we have VA times 0.87 angle negative 16.7 minus VB times 0.5 equals 37.5 angle minus 70. Equation 1. Now for VB, we have 1 plus 1/2 plus 1 over negative J2. So these are the admittances linked to that node, minus VA times 0.5 minus 150, the supernode, angle 20 times 1 equals 0. So if we simplify this, we have VA times 0.5 plus VB, we have 1.581 angle 18.435 equals 120 angle 20. Equation 2. And let's construct our matrix. We have 0.87 angle negative 16.7 negative 0.5. The other elements, we have 0.5 and 1.581 angle 18.435 with VA and VB equals 37.5 angle minus 70, and 150 angle 20. Correction, this is 150. And so if we perform Cramer's rule, we have for VA, one 0.329 angle negative 10.963 all over 1.1257 angle 2.120, and so VA is equal to 97.121 angle negative 13.083 volts. And for VB rather, using equation 1 or equation 2, either of the two equations, the VB should resolve to 121.764 angle negative 6.35 volts. And so we can now solve for the current flowing through that resistor, the 2 ohm resistor. We have VA minus VB all over 2, and this results to 13.879 angle negative 162.124. So alternatively, instead of solving for the voltage, which is the VA minus VB of that resistor, I would prefer to use this formula. We have 1/2 times magnitude of the current flowing through that resistor times the element. So for our Z, we have a value of R only, and so we have P equals 1/2 times 13. So take only the magnitude of your current. We have 13.879 squared times resistance. We have 2. So the power absorbed of the resistor is equal to 192.627 watts. So it is definitely a real value of power because we have a resistive load. So this is the answer.